Okay, so what we're going to talk about today is profit maximization, and this is the theoretical part of our course. And we've got we're going to model three different types of markets. So we've got um, perfect competition. We've got monopoly, and then we have monopolistic competition. Okay, those are our three different types of markets. So here, what we're going to do is actually look at monopoly. So we'll do monopoly here. Okay, so in the case of monopoly, we have the firm is going to equal the market. Okay, why? Because there's only one firm in the market. Okay, that's the simple explanation there. And so we can model these together, and we're doing it graphically here. And this is graphical instead of using maths. We've got price, quantity. Remember, these are actually derived. These curves are derived from maths. So okay, and so what we're going to have actually is that a monopolist is going to face a downward sloping demand curve, and that's the biggest difference between monopoly and our perfect competition model. For one, in perfect competition, remember, lots of buyers and sellers all selling the same thing. Here we only have one seller. And because we only have one seller, the firm has some price, they actually are price makers. So the firm here is a price maker. And what does that mean to be a price maker? That means that the firm's choice of quantity that they actually produce is going to influence the market price. That's why they're a price maker. Remember, in perfect competition, the firm faced a perfectly elastic demand curve, meaning that no matter how the firm chose to produce, no matter what quantity, it had no influence on the price. They're price takers. So this is a price maker, meaning graphically, meaning that it's facing a downward sloping demand curve. So here's our demand curve, okay? And we're drawing a linear demand curve. And there's actually some simple types of calculus that would be super helpful in talking about this that unfortunately, we're not going to be able to do because this isn't a calculus type course. But you're going to need to trust me on this a little bit then, because I'm going to just tell you a few things about what marginal revenue looks like here. But actually, if you wanted to know the calculus, so if price is a linear function of quantity, meaning so remember, price is some m. So linear is mx plus b. So I'm just going to write the slope. So you mx plus b, where m and b are constants. Then actually the slope of this thing is m, right? That's how this is changing. So actually, d price over dq is going to be equal to m. Okay. That's how our price is changing with respect to our quantity. And so this is kind of the big point, is that the price does change with quantity, and it's going to change by the slope. Okay, so the marginal revenue, remember, this is the change in total revenue for a change in quantity. Okay, I'll write it in terms of deltas instead of these so you don't get confused. So change in total revenue for a change in quantity. Remember, so here actually price is a function of quantity. And so marginal revenue, without getting into the calculuses, I'll just tell you straight up, it'll start at the same origin. Start from the same intercept point, and it's going to actually bisect right in the middle of. So if this was, say, 10, it's going to bisect this at 5. It'll hit right in the middle on the x-intercept or the q-intercept, and it'll be a straight line too. That's my marginal revenue curve. I'm going to save you the calculuses. Unfortunately, I really do like calculus, and I wish we could talk about it because it would make things a lot more clear, but you just got to buy into that. But this is actually the marginal revenue curve, and here's the demand curve that the firm faces. So that's the big difference. All the rest of it is actually fairly the same. So remember, the story is that firms are here to max profit by choosing a Q, and profit is equal to total revenue minus total cost. And there is an optimal condition. The optimal condition is where marginal revenue equal marginal cost is associated with one and only Q, one Q. So this is the story in perfect competition. It's the same story here. And so we need to draw some cost curves onto this. So so we could have something like average total cost, and let's just do average total cost and marginal cost. Ooh, the pen's going bad. Let's see if the other side works better. Marginal cost, that does a little better. Okay, so look, where marginal revenue equal marginal cost. All of these problems, you need to just start with trying to figure out what's the optimal Q. Once you get this optimal Q, then you can figure out everything else. So where's this Q? Well, marginal revenue equal marginal cost right here, but actually is associated with this Q star, okay? Now, now we can calculate profits. So now this is where it's going to be a little different. Look, remember, so you might be able to ask, like, what's the profit? Are they earning profit? Are they earning losses? Okay, all these things. So so profits, first off, we have total revenue minus total cost. Remember, total revenue is price, which in this case is a function of Q. That's going to be determined by our demand curve, okay? Times Q minus total cost. So I'm going to write everything in terms of Q here. Okay, so minus our total cost. Total cost is going to, we have average total cost, so that's going to be average total cost. Look, this is a function of Q also. So this is average total cost, a function of Q, times Q. Okay, because remember, total cost is equal to ATC over Q. So that means if I just multiply both sides by Q, oh, sorry, no, I got that wrong. Sorry, ATC is equal to total cost over Q. I'm sorry. Space out moment there. Average total cost, this is the definition of average total cost. It's total cost over quantity. So if I multiply both sides by Q, I end up with this coming out. And average total cost is a function of Q itself, as we can see up here. So we just need to solve this equation to get profits of Q, okay? And we're looking at specifically at the point Q star. So we only care about the point Q star now, because that's the optimal quantity. Okay, so how do we calculate this? P of Q at Q star. How much are consumers willing to pay at Q? Well, that's determined by the demand curve. So there we go. There we go. This point is going to be P of Q star. Right there. So it reflects. So first step, find the optimal Q. Second step, after you find that, everything else comes into play. So that's the price consumers are willing to pay for this quantity, and then times Q star. So that's the total revenue. Total revenue is actually going to be represented by this box right in here, this whole box. Okay, that's total revenue. Total cost. Let's do it in a different color pen. This one's kind of dying on me. Anyway, so we'll do it in a highlighter. How's that? Total cost, ATC. So remember, average total cost. This is a function of Q. We see here. So what is it at Q star? Average total cost. Right there. There's my average total cost at Q star. Right there. So ATC times Q. Here's Q. There's ATC as a function of Q. Just reflected right off that curve. And what we're going to end up with is total cost is going to be equal to this box. See? Just like that. And then, obviously, the difference between the two. So here I got revenues greater than cost. And so this smaller little green box will be my profit. And that's how to solve it on a graph. Now, you're going to also have things that are solved in terms of tables, but they're going to follow the same exact kind of process where you might have some table where you have some of these values listed out, and maybe you have to calculate average total cost, or maybe you have to calculate total cost, or there's different types of ways that they can give this to you. But just remember that in the end, the firm is really trying to maximize profit. So even if you have a table, the first thing you should look for is what quantity satisfies the condition where marginal revenue equal marginal cost. Okay, that's the thing you need to answer. there's only going to be one quantity really that satisfies that condition or maximizes profit. In a table, I will say sometimes you will end up with two. Maybe maybe this condition never exactly holds, and so you might end up with two kind of right in the neighborhood. You can always come back and just look and ask yourself what quantity maximizes the profit. So in other words, calculate profit for different quantities, and then figure out which quantity maximizes profit. That gives you your optimal Q. Once that's the first step in all these problems. The second step is to try to answer other questions like how much profit did they earn? Well, to answer that, you have to calculate profit. Or what's the total cost at the optimizing Q? Well, you can calculate these different boxes. You can calculate that on tables. You can do it on graphs. I did it on a graph right here, and that's pretty much how you're going to have it in a lot of your problems. You're also going to have some tables, but we can do an example with a table. It's not really that much different. In fact, I might just do that next. So with that said, hope this video helps. Please let me know and send me a message if it's good, bad, if you need something else. I'm happy to accommodate you.